Sorry. Absolute values. Let's go. Remember, I'm gonna stick with that betweener and splitter stuff. So treat them like radical equations. So in radical equations, what did we always try and have to remember? We had to isolate the radical. So in this case, we have to remember to isolate the absolute value. So let's go absolute value 3x minus 2 is equal to, I don't know, 4. Something easy like that. Okay? So we can actually graph this stuff too, but I'm not too worried about it. I don't think I put any of that kind of stuff there. Ones? Do they? Well, they're not ones. They're absolute value brackets. Okay. We know that this bracket, though, can equal what? Positive or a negative. So we'll set both those up outside of the absolute value bracket. So always 3x minus 2 equals 4. And 3x minus 2 can also equal a negative 4. Trying to think here. It's the same way, isn't it, with the inequalities? When we do absolute value inequalities, it's always the same. That's what I always write down first. So if it was less than 6, we would put down less than 6, or greater than 6, or greater than 6, that kind of stuff first. And then it's always the opposite with the negative, right? And I think that I can explain it. If we divide by a negative 1 or multiply it by a negative 1, across an inequality, what happens to that sign all the time? It flips. So that's why. So I always kind of just take the original and do it. So anyways, once we have this, we can just solve it the way it is. So in the first one, we'll add a 2 over. So I get 3x equals 6. Divide by a 3. X equals 2. So there's first solution for x. We can do the same thing over here. Add a 2 over. That goes, we get 3x equals negative 2. And divide by 3. Oh, not negative 3, sorry. Positive 3. So x equals a negative 2/3. There it is. There's our solution. Pretty simple. The only thing extra that I could throw at you for just the equation stuff is if I had a number with on the same side as the absolute value, we just have to get rid of that before we started. Any wild and crazy thoughts, questions? No? What if this 4 was negative? Yeah, because an absolute value can never equal negative, right? It always comes out just the distance from 0, right? So, all right. Let's do an inequality. Same stuff. Just we'll end up doing 2 examples. Splitter and betweener we'll call them. Let's go with the betweeners first. Okay? And this is the one that seems natural to me. I don't know why. But we'll go like this. We'll say absolute value 4x minus 3 plus 4 is less than or equal to 9. Okay? So I'm calling this a betweener. How do I know this is a betweener? Well, I don't yet know. Okay, I don't yet know. Because of the way it is, the absolute value isn't isolated yet. Once that's all isolated, I can look at it a little closer. What do I got to do first? Minus the 4 over. So I'm going to minus this 4 over. That'll disappear. And I end up with the absolute value of 4x minus 3. Whoops. Then what do we know about that? It depends on the sign on that one. Because if it was greater than a negative, Sarah, we could have that. But we can't have less than a negative, right? So that kind of stuff comes into play. So 4x minus 3 less than or equal to 5. I got to really get in shape. All that running tired me out. That's pathetic. Okay, oops. These are absolute values. Sorry, my fault. So now I can look at it because the absolute value is isolated. This is why I know it's a betweener. Okay, because of the less than sign. Do I have to write it that way? Yes. Okay. So when I set this up, I know, remember what I just finished saying, how you write down the original? This stays. 4x minus 3 less than or equal to 5. That doesn't change. Give me a number that's less than 5 though. 4. So if I think of negative 4, if I made that a positive, really that negative 4 though is greater than negative 5, right? So negative 5 is less than those numbers, right? Negative 5 is less than a negative 4, right? So now our solution, or our x's, our equation, part of it, is between the two possible results here. So I'm going to add the 3 to both sides. So when I do that, I get a negative 2 over here. 4x less than equal to 8, like so. And then I divide by 4 on both sides. So if I had the negative here though, if I had a negative 4 and I was dividing, what would happen to our inequality signs again? They'd flip, yeah. So we got negative 1/2 less than or equal to x, which is less than or equal to 2, once I divide all that out. So there's our solution. So any x value in between there is going to make that whole inequality true. Okay? And we could graph that and see that, yeah, that's true. That's where it is. Okay? Nothing to it. So that's a betweener. How to draw? I'm not going to expect you to do that, I don't think, Caitlin. Well, we can do it, I guess. Yeah, let's do it. Why not? Or should we do an equation? We'll do that later. We'll do that after. We'll do a splitter first, and then we'll do that. What's that? That's good enough. It's up to you. Remember, both ways, it doesn't matter to me. I'm happy with that. Well, then it's still going to look like this, right? And like Crystal said, I could put the like set notation there as well. So you should know both ways, but for you to write the answer, it doesn't matter to me. Whatever you're most comfortable with, go ahead. But it's pretty easy to tell what this is going to be, right? It's going to be from -1/2 to 2. You know, those ones? So now, let's do a splitter one. I honestly don't know why or where I started calling them splitters and betweeners, but it just makes sense in my head. Might not make sense in your head, but let's do another one. Let's go -3x plus 4. We'll just say greater than 7. Okay. How do I know this is a splitter? Yeah, the greater than symbol, right? And I'm going to take that and I'm just going to write it down again. Just the way it is. Just like I said, every time you write your original down, greater than 7. Now I've got to think of that though for a second, because that's how I try and figure out the other side. What's a number greater than 7? 8. So now if I think on the negative side of that, negative 8, okay, is -8 less than or greater than -7? Less than. So -3x plus 4 is less than -7. Right? Because you just said -8, because it's going to come out a positive, right? But -8, well, that's less than -7. That's how I figure out that sign on the other side. Okay? Solve each side. So minus a 4 here. I get -3x greater than 3. What's going to end up happening here, grade 11s? I'm going to flip that inequality, because I'm going to divide by a -3 across the inequality. So I get x is less than -1. Okay? And over here, it's going to end up doing the same thing. Minus a 4, so I get -3x is less than -11. When I divide that -3 out across the inequality, I get x is greater than 11/3. Okay? So, just real quick, we know that that's got to be where it is. So, on this one, -2 would work, right? Because if we plugged a -2 up here, we get 6 plus 4 is 10. Absolute value is 10. Is greater than 7. It works, right? Over here, 11 divided by 3, that's 3 2/3. So we'll say 4 just to make it easier, right? Because x is greater than 4. So, or x is greater than 3 2/3. So put a 4 in there. I get -12 plus 4 is -8. Absolute value is it's greater than 7. So both work. Now I'm going to do it in that set notation for you, so you can see what this one look like. Less than -1, and I mean less than, forever, right? So if we ended up here, because when you divide, because I could do it two ways. I could add that 3x over here, right, Sarah, and then minus this 3. So then it would just be 3 is less than 3x, and then divide the 3 out, and it's going to be x is less than -1. You got it? Okay. So let's go like this. All the x values. No, just when you divide by a -1. But you've got two split solutions. Yeah, you do the same thing. Yeah, flip those signs. Yeah, exactly. Let's go like this. Here's one way we can say x is less than -1, and x is greater than 11/3. So you can write it like that. That's the one way we would write this solution. Or if you left it like that, I'm not going to ding you at this point of the game, right? You guys have seen that 1,000 times now, so go ahead, right? The other way, what would I do? I would say from -infinity all the way to -1. Oh, yeah, it's not equal to, so it's a round bracket. And that's union with 11/3 all the way to where? Positive infinity. And again, round bracket. So we can do it those two ways, right? And again, it doesn't matter to me. Should be comfortable both ways. Okay? Okay?